All right. Hi everyone, my name is Sophie Barrett and I'm a work health and safety consultant at Safe Design Australia, and Safe Design Australia are a work health and safety consultancy that specialises in assisting designers in discharging their duty under safe design legislation throughout Australia. My background is in architecture and work health and safety, so I come from a design background, so I do understand the process of design as well. I'd like to just firstly thank David Springett and Steve Kennedy for inviting me to speak today. They did mention that a few of you had concerns about the legislation and how to put it into practice in your workplaces. So hopefully we can help you with that today. I'd just like to start firstly with a short story from my personal experience of safe design. It has impacted on my family's life. In fact, my father suffered from emphysema as a result of working with paints over many years. And as you know, paints used to have a lot of fumes and volatile organic compounds in those. So he contracted emphysema as a result of working with paints and then had to be on an oxygen machine from his 40s and ended up dying early in his 60s, and that really impacted my husband's family. So these are the kind of things and the accidents and injuries that the safe design legislation can have an impact on. So it's about actually improving the safety for people and their families. All right, so what we're going to do today is we're going to cover the safety in design, and we're looking at risk assessment, and we'll be looking at some examples and case studies. So I'll just stop sharing the webcam there. We'll do some questions at the end, so if each location can type in 3 questions in the chat panel, we will answer those after a 5-minute intermission after the presentation. So we'll just get started straight into the presentation now. Thank you. So just a few technical issues. I think we've sorted everyone out with sound and visual and audio, but if you do have any problems, there's a number there to call, and just press 1 or 2 and they'll be able to troubleshoot any issues with you. I mentioned about each location providing 3 questions, and at the end, if we do have time after the questions, we'll open up the microphone to some voice questions for those who have that facility available. CPD points will be available, and we'll email you a copy of some questions that you can keep to use to gain 1.5 CPD formal points from the AIA, and you'll also be sent a certificate of attendance. We'll also be sending you a PDF copy of this presentation and a link to a recording of this webinar, so this will be recorded so you can have a copy later on, and an information pack on safe design, which will include a fact sheet for designers, a fact sheet for clients, and some work health and safety notes for your plans. So today we're going to be covering firstly the legislation and the requirements. We will then talk about how to systematically evaluate your design and about risk assessment and what that involves. We're going to be looking at the life cycle of the structure and providing some pictorial examples of these. We'll then go to talk about reporting and record keeping, and finally we'll finish with a case study on Prince Alfred Park Pool, and then we'll have our question and answer session at the end. So I've been presenting around Australia to architects and building designers, and I usually start the presentations with a question and a poll about what their concerns are about the legislation. The way we've got it set up today, we can't do that, but I thought that I'd just show you these results. There's over 200 architects have contributed to the survey. The main concerns there are concern due to lack of knowledge on safe design, 44%, concerned about being prosecuted, 31.5%, concerned that the legislation will negatively impact their designs, 19%, and 5% were not concerned at all. So this is quite common, and these results have been showing each presentation we've been giving, that the main concern is due to lack of knowledge on safe design. So hopefully this presentation today will help you in understanding more about your safe design requirements. Second concern about being prosecuted. The best way to cover yourself from being prosecuted is to make sure that you do discharge your duties under the legislation. So we'll be giving you some more information about how you can best do that as well. The third concern, that the legislation will negatively impact your design. We have a really good case study that shows that design and creativity can actually be enhanced through safety, and it's the Prince Alfred Park Pool by Neeson Murcutt Architects. And for those of you who aren't concerned, that is great. So what is safe design? Safe design is the integration of hazard identification, risk assessment and control methods early in the design process to eliminate or minimise risk to health and safety throughout the life of that structure being designed. So the intent of this legislation when it was brought in was to target what they called upstream duty holders. So these are people that have impact early in the process, and research has shown that up to 2/3 of injuries could be prevented if safety had been considered at the design stage. There are many benefits of safe design. So I mentioned prevention, so going right back to the source there, providing safer workplaces and reducing the amount of injuries and deaths. It's also about improving the usability and productivity of the workplaces that we are designing and coming up with innovative solutions to safety issues. Okay, we'll just discuss the overview of the legislation now. So I'm just starting with the basics of the legislation. You may have heard some of this material before, but as I was unsure of the what information people have been receiving, I just thought I'd start with the basics. So forgive me if you've already heard the information before, and just consider it as a bit of a refresher. This is the harmonisation process. You may have heard that Safe Work Australia has written a model legislation that has been adopted in each of the states and territories around Australia. Now the legislation is enacted on a state-by-state basis, so it has to be enacted in each state. So far, New South Wales, Queensland, ACT, Northern Territory and the Commonwealth commenced the legislation on the 1st of January 2012. Tasmania and South Australia commenced the legislation on the 1st of January this year. Victoria and WA have yet to enact the legislation. They do already have quite strict safe design legislation involved, and the research has been showing that they're saying that it's going to be costing too much to upgrade to the new legislation, and the cost may outweigh the benefits. So at the moment they're delayed, but they are likely to come on board in the next couple of years. So this is a bit of an overview of the safety legislation and how it all fits together. At the top you've got the Act, which outlines your duties as a designer. Underneath this are the regulations. So these are more detailed information about how you can fulfil your duties under the Act. Below this are the codes of practice, which are guidance material, and you need to comply with these codes of practice unless you can achieve a higher result. For example, if an Australian standard has a higher level of safety than the code of practice. Below the codes of practice are standards and things like Australian standards, and then down the bottom are industry standards and guidance notes. And this is including things like the National Construction Code or Commercial Kitchen Guidelines and things like that. So the main duty of designers of structures is to ensure, so far as is reasonably practicable, and I will mention what that is in a moment, that the structure is designed to be without risk to the health or safety of persons who use the structure for the purpose for which it is designed, who manufacture or construct any component of that structure, or who are involved in the maintenance or disposal of that structure. So it's a whole life cycle consideration. Now, where they use reasonably practicable, when you're looking at identifying hazards in your design, firstly you need to look at the likelihood of that hazard occurring. The second consideration is the degree of harm that could result from that hazard. The third one is what the designer knows or ought reasonably to know about ways to eliminate or minimise that hazard. And 4 is the suitability or availability of ways. And finally, at the bottom, after assessing all of the above, is the cost. So it's not applicable to say this costs too much, we're not going to put in that safety feature. If there is a high risk of death or injury, the cost isn't going to be something that will protect you. But where the cost is disproportionate to the actual hazard. So for example, if there was a minor hazard like you could kick your toe on something and you had to spend hundreds of thousands of dollars for a safety feature that might address that, that wouldn't be reasonably practicable. So cost can come into it, but it's at the bottom of the list. So here's a pictorial sort of summary of the stages that safe design needs to be considered. So it's throughout the life cycle of that structure when it is used as a workplace. So for commercial buildings, it includes all of these phases, which is firstly the construction, including site establishment, the use of that structure for the purpose for which it is designed, the maintenance, cleaning and repair of that structure, and the demolition at the end of life of the structure. You also need to undertake any testing or analysis necessary to fulfill those duties and consider people in the vicinity of that workplace. There's a little note there that said the use for purpose isn't applicable to residential. So with residential, you're looking at the construction, maintenance and demolition phases because that's when that residence is a workplace. It isn't a workplace when being used as a residence. There are some exceptions to this. That is if there is a home office or a workshop or if there are permanent staff employed at that residence, then that home would also need to be considered the hazards during the use of that structure. Now this is quite an important part of the legislation. They've put a specific duty in here to consult with other duty holders. So basically where more than one person has a duty in relation to the same matter, so if more than one person is involved in the design of this structure or like the client or other people, these people must consult with each other to make sure that they improve the safety of that structure. So this includes consulting with people such as consultants, so other designers. Now the definition of designers is quite broad. It includes not only architectural designers but structural engineers, interior designers, hydraulic engineers. All of the different engineers are considered designers, and landscape designers as well. The client is a duty holder, so you need to consult with the client, the builder or principal contractor if you know who they are. So obviously you can't consult with them if you're not aware of who they are. Designers and manufacturers of plant, and there's a specific duty in there to consult with workers or their work health and safety representative. So if you are designing a workplace for a company, you need to consult with their workers or work health and safety representative on safety as well for that workplace. So what information should you provide? There's two sections in the legislation about providing information. One of them is in the Act. So the Act basically says that you need to provide information to anyone who is issued with a copy of the design, indicating firstly the purpose for which that structure has been designed, the results of any testing and analysis that you've undertaken, and any conditions necessary to ensure the safety during the life cycle, so the construction, maintenance, use and demolition. There's also a specific section in the Act to provide that information on request. So someone comes and requests that information of you, whether it's someone constructing or maintaining the building or demolishing it in future, you need to provide that information to them on request. On top of this, there's a specific requirement in the regulation for a construction safety report. Now, a lot of you might have heard of this safety report and are not sure when it's required. The WorkCover New South Wales are currently working on a legislative guide on the safety report, and basically what they're saying is that in most situations you will need to provide a safety report. The only situation they mentioned that you may not would be a standard single-storey brick veneer home in a housing estate which is built with standard techniques. So at any other time you would need to consider safety and provide a safety report. So the safety report that's mentioned in the regulation is actually mainly concerned about construction hazards. So there's a three-step process in the regulation. The first step is that the client must consult with the designer. So that's the first step. Then the designer must provide a safety report to the client detailing hazards that firstly create a risk to persons who are to carry out the construction work, and B, are associated only with a particular design and not with other designs of the same type of structure. So these are features that are unique to that design that might pose a risk to health and safety. Now the client needs to give information. The client is then required to pass on that information to the builder. There are other duties in the regulation for designers. There's a specific requirement for designers to ensure that the need for hazardous manual tasks is eliminated or minimised as far as is reasonably practicable, and that the need to enter confined spaces is eliminated or minimised, and that confined spaces have a safe means of entry and exit. There are also a few other sections in there, if they're relevant, that are listed below. Clients also have a specific section in the Act which explains their duties as well, and their duties are quite similar to those of the designer. So the client who commissions the construction work must ensure that the way in which they commission that structure is without risk to health and safety of people who construct the structure, who maintain, clean or repair the structure, who use the structure for the purpose for which it is designed, and who demolish that structure at the end of the life. So the same life cycle considerations. The client must also consider people in the vicinity of that workplace and consult with other duty holders. And as I mentioned just before, they have a specific duty under the regulation to consult with the designer regarding health and safety and to provide the designer's safety report to the builder. So what are the legal implications for designers? There are a number of fines and penalties that do apply. Prosecutions tend to apply where Category 1 offences, so the most serious types of offences, if the designer is shown to be negligent. But they have to prove a direct link to the designer and negligence as well. Category 1 offences are permanent disablement or death, so these are the most serious offences. But in most cases, what the regulator tends to prefer are things like enforceable undertakings or training orders, because the intent of the legislation is to improve safety. So for example, if you had designed a plant door on a plant room and it had exploded outwards and you hadn't considered the correct design of that door, instead of fining or prosecuting you, the regulator may say to you, you need to go around Australia and talk to all the architects associations about how to safely design plant doors, because that would actually improve the safety and that people would learn from that experience. So training orders are also used. Now there's two types of law, and a lot of you may know this, but I'll just briefly explain the two. Common law is developed by judges through the decisions of courts. So that's where someone could sue you if an accident occurred as a result of the design, and they could link that back to the design. This has already been in place, so that this hasn't changed. This is always applied to designers. What has changed is this statute law. So this new Act is a statute law, so each of those, the Act is a statute. So that's written law set down as legislation, and that is enforced on a state level. So this is where if someone is injured or there's an accident, that the Crown can prosecute you because in the breach of that legislation. So insurance is another thing that people are concerned about. So does your professional indemnity insurance cover you for this legislation? In many cases they don't, and we have been finding that insurance companies are starting to cover people more. So some do cover you for costs as long as you're found not to be reckless, but not fines. So some of them do cover you for some things, but it's worth talking to your insurer and making sure that you know what is covered. You can take out additional cover for prosecutions and fines, but that's quite expensive and it may not cover you in all cases. So the best way to cover yourself is to discharge your duties under the legislation and design the structures to be without risk to health and safety and provide the information required. That will protect you against any potential legal action. Another thing to consider is changing insurers. So if you are looking at changing insurance companies, you need to make sure that they set your retroactive date back to unlimited, because if you have designed a structure and someone has an injury, or maintaining that structure or demolishing it in the future, as this lasts for the whole life cycle, and you're not insured with that same company, you won't be covered. So making sure if you do change insurers that they cover you for your work prior to that date. Also, it's important to make sure you have ongoing cover if you do retire or stop working in some way, that you have some kind of run-off cover, because there isn't an actual limitation on this. Goes for the life of the structure. All right, so we'll just talk a bit now about a systematic evaluation of your design, and this is what is recommended by the Code of Practice. So the Code of Practice recommends that the designers follow a risk assessment process. So that's about identifying any hazards, assessing the risks from those hazards, and coming up with some design controls. And I personally wouldn't like to be doing the safety report for the one on the right there. There's going to be a few construction hazards with that one. So this flowchart comes from the Code of Practice, and it really explains it and makes it a lot clearer. So firstly, at the top you've got the initial design context and consultation, and then you identify any preliminary hazards. So When you're looking at identifying hazards, the third one is very important. It's identifying hazards that are affected by the design and are within the control of the designer. So you're not concerned with hazards that are not part of the design and that are not within your control. So that's firstly eliminates a lot of concerns that people have. Some people say, well, I don't know what's going to happen on the construction site. That's not your concern. It's things that are affected by the design and are within control of you as the designer. The next step is to determine how any of those identified hazards will be prevented or eliminated through either A, implementing standard controls, or B, conducting a risk management process. So this is another important step. So I've highlighted implement standard controls. And what that means is if you've identified a hazard and it is covered by an Australian standard, a code of practice, or the National Construction Code or some other guideline, then you don't need to do a risk assessment on that particular hazard. So in a lot of cases, a lot of hazards during construction and things like that will be covered by these guidelines. So that's an important step to remember. If it isn't covered by those standards, or the Australian standard or guideline isn't adequate to address that hazard, you need to apply a risk management process to that hazard. So I'll give you an example of a case where an Australian standard may not be adequate. You may be designing a childcare centre that has a veranda and there's some play furniture out there. A standard 1 metre high balustrading would not be adequate in that case because kids could drag the furniture over and climb over and fall off the balcony. So you'd have to go beyond the Australian standard in that case. So you've got to actually look at each risk and whether the standard is adequate to address that. Then you need to apply some design controls, come up with some design solutions to either eliminate or minimise those identified hazards, and then to review your design to see whether that hazard has been eliminated or minimised. Then presenting your final design with any hazards identified and recommended control measures. So at this point you'd be passing on also any residual risk to the builder. So if there's something in the structure that you haven't designed out, for example, you may have used CCA treated timber and you haven't designed that out, you'd be passing that on as a residual risk to the builder to ensure that they used safe practices on their site to manage that risk. So when you're looking at evaluating your design, there's a number of hazard areas. These are just our list of hazard areas, but there's another one in the Code of Practice that you can go through to evaluate your design. And this is about following a systematic hazard identification process. So firstly, you go through access. Are there any issues with access on this particular site? Electrical. Are there overhead power lines? Is there underground power or high voltage power lines? Hazardous substances. You might think it could be an existing renovation and there might be asbestos in the existing building or lead-based paints. So going through that list and working through to come up with any potential hazards under those categories and listing any potential hazards. Okay, this is a risk matrix. So when you're looking at identifying any potential hazards, it's a good idea, and it was recommended in the Risk Management Code of Practice, to identify what the risk level is before and after the design control to show that you have either eliminated or reduced that hazard. So I'll just illustrate this with an example. Let's just assume that we have a structure on a steep site with prefabricated roof trusses. So there's a potential hazard there for crane tipping. So the crane could potentially tip over. It's a very steep site and you've specified prefabricated roof trusses. So when we look at the consequences, so if there's a potential hazard there for crane tipping. If that crane tipped over, how severely could someone be hurt if it happens? So if you look across the top there, it's potentially catastrophic, so someone could potentially die if that crane tipped over. Now we look down the side to the likelihood. So how likely is that to happen? How likely is that crane to tip? We might say that on a very steep site it is possible that that might occur. So if we take those two lines across, we have an acute level of risk. So that's a very high level of risk, so we need to do something to reduce that risk. So some of the solutions we could look at the design stage would be maybe to move the structure up the slope so that it is accessible by a crane,
We could change the roof structure type so we didn't have prefabricated roof trusses and didn't need the crane. We might have a driveway there and there's actually going to be a stable area at the bottom from the driveway for crane operation, and we might decide to ensure that that driveway is designed so that it can take the load of the crane to lift those roof trusses onto the site. Or we might even consult with the crane operator or builder and find that there actually is a crane that can be used on that site and that it isn't an issue at all. So let's just say that we decide to construct the driveway, make a recommendation that the driveway is constructed first and ensure that that driveway is designed to take the load of the required cranes, and there is a stable area now for the crane operation. If we look at the risk level now, we look at the consequences, so how severely could someone be hurt if that crane did tip. It's still catastrophic, so people could potentially die, but the likelihood of that crane tipping now has been brought down to rare. So we've reduced that from an acute to a high level of risk. Now that high level of risk then can go on to the builder to manage through their safe work method statements and job safety analysis. So sometimes at design stage the risk levels will still be high. Certainly where there is a risk of death, it's really hard to reduce that below high, but you've shown that you've reduced it as much as you can at the design stage, and then the builder is working on their own procedures to bring that risk down further and make it workable in their situation. And there's a pictorial example of a similar situation where they had to use the driveway of the house next door to lift those with 2 cranes and have the spotters on the house behind, because it was on a sloped site, that one with trees in front. So when you're looking at implementing controls to eliminate or minimise the risks in your design, there's a hierarchy of risk control that you should follow. The first on that list, starting at the top, is elimination. So ideally you should be eliminating or designing that hazard out, so that hazard's been removed 100%. For example, you could eliminate the risk of working at heights by relocating plant like air conditioning units to the ground level so that people don't need to work at heights to maintain those. Substitution is the next one, so substituting a material with something of a lesser risk. Might be using no VOC paints rather than a more toxic product, or specifying steel posts instead of timber in a childcare centre to reduce the risk of splintering. Isolation is the next one, so isolating any hazardous plant or chemicals. Engineering controls, so things like wider corridors for plant access or mechanical ventilators. Administration and training, so these are softer controls, so this is communicating things through traffic management plans or signage. And finally, right at the bottom you have personal protective equipment, so you're actually stopping the hazard at the person's body, which is the least effective method of risk control. And I think in that case the guy's hair would probably have more protection than the hat. So we'll just go through some pictorial examples now of the life cycle considerations. So we're going to look at construction, use, maintenance and demolition. Firstly, when you're looking at the site, and you'll all be doing this anyway when you're designing buildings, looking at any particular site factors, so things like earthquakes, floods, cyclones, if you're in a bushfire zone, whether there are contaminated soils on the sites or acid sulfate soils. So these things can all affect safety. During the construction, this is an example here of in residential construction, the Code of Practice actually recommends that the roof trusses be spaced at 600 centres and or battens at 450 centres. Now the codes of practice, and there are a lot of different codes of practice, things like construction work, asbestos, demolition, housing construction. So these codes of practice are based on research that the regulator has undertaken on injuries and risks, and that's all in those codes of practice, so you really should be starting to be familiar with these. So this particular code of practice does recommend that there's the ideal spacing, because a lot of people have died from falling through roof trusses. It can also be things like hazardous materials, as I mentioned before, so things like earth wool, which is a product that actually has no formaldehydes or VOCs. Your E0 cabinetry or your low VOC paints, alternatives to things like treated timber and MDF. There's actually an Eco MDF now that has no no emissions. So it's safer for people to work with those products. And you can specify these in your designs. Asbestos is another big one. Now, buildings prior to 2003 have potential to have asbestos in them, and this date has changed to 2003 due to the fact that asbestos may have been stockpiled in some locations and been used. So with commercial buildings, they will have an asbestos register, or they should have, by the legislation requirements, they should have an asbestos register, but you might need to have a hazardous materials survey undertaken on the structure if there's potential asbestos or any other hazardous materials. Prefabrication can actually improve safety, so you can reduce the risk of working at heights by specifying things like prefabricated roof panels or stairs, or even whole prefabricated buildings. With services, you can specify that the mesh runs through the floor so that people don't fall through void spaces, or that services are sleeved or have metal mesh through to prevent falls during construction. So these are just a few of the things, including things you can do to reduce manual tasks. There might be air conditioning units that you can specify that are easier to install and lighter. Thinking about working at heights, that's a big one where injuries are involved, hazardous substances, any high-risk construction work. But also thinking about the demolition of existing structures if you are looking at a renovation and any potential hazards there. So the next part of the life cycle is use for purpose. So this is an example that was used in one of the AIA presentations. This is a residential house, so it's not specific to this legislation, but about balcony safety, as things like live loads on balconies and ensuring that structures have been designed to take potential loads. In this case, the balcony was overloaded from a school function, and it did collapse and people were killed. But how this would apply in the safe design legislation would be for commercial premises. If they are going to have a function there, you need to ensure that those spaces are designed to take the live loads that might occur. It's also other things in this situation that might be in control of the designer are, for example, if you're designing a deck area in a tropical environment, you might need to specify particular types of timber that are more durable and less likely to deteriorate. Or if it's, say, a deck in a coastal environment, the types of fixings and fittings that you would specify would be things that were anti-corrosive, so to ensure that these kind of situations didn't occur. So those are things that you could control as a designer. What you can't control are things like ensuring that people maintain those things later in their life. So that type of stuff isn't reasonably practical to be in your control, but you need to control what you can do at the design stage. Foyer safety, so this is things like recessed entry mats, making sure that they're not a trip hazard, non-slip floor surfaces at the entry. Light amenity and ventilation are also part of work health and safety, so creating adequate light and ventilation for workers, and psychological hazards are also considered. Fire safety is one which we'd be very familiar with, and this is also considered. So not only meeting your obligations, but ensuring that there aren't any things that aren't covered by the requirements that may be considered. For example, you might have gas bottles near an ignition source, or you might be able to propose a better method of evacuating the building than the one that you originally proposed. So re-looking at those things and making sure that fire safety has been considered from a workers and user of the building perspective. Access for persons with disabilities is part of the requirements. And also things like isolating hazardous substances in the workplace, so things like a lockable chemical store or isolating gas bottles and things like that. So when you're looking at use for purpose, and I feel this is the most important part of the legislation because it's about what architects do really well. It's about really understanding what's happening in that workplace, what type of systems of work are happening, what things could occur there and what things could potentially go wrong, and making sure that you consider those at the design stage. And this is where you have most of your control. So things like making sure there's adequate access. You might be putting in double doors where people need to bring in large pieces of equipment or near loading docks. The types of plant that you use, manual tasks, what can you do to ensure that manual tasks can be easily completed? Do you need to have access for trolleys or mini forklifts or pallet jacks or something in a storeroom, that type of thing. Loads on floors is important, so if there's going to be a large piece of plant on an upper floor, making sure that the floor is designed to take that load. I mentioned psychosocial stresses, so things like occupational violence, so people working in types of things like service stations or places where money is being collected might be exposed to that, and what can the design do to assist in that. And making sure things like on the site layout and everything is correct in terms of making sure that vehicles aren't walking behind people aren't walking behind reversing vehicles, and that vehicles and pedestrians are separated. There's a lot of considerations, and these are the things that you're doing every day as part of your designs. The life cycle, next part of the life cycle is maintenance or repair. So these are a couple of examples. On the left there you can see that they've provided a perimeter path around the building. So this will allow for this building to be easily maintained during its life. On the right, box gutters. So in areas with high trees, you might reconsider in your design the use of box gutters. If you do use box gutters, coming up with another control like things like gutter guards and things like that that will manage any potential hazards of people. So this is about decreasing the risk of people working at heights to clean those gutters. Window maintenance, so where you've got voids and things like that, making sure if you do have high-level windows, ideally they can be cleaned from the inside, so openable like louvers and things like that. The example in the middle has some hanging lights which can be easily changed. The example on the bottom left there, you can see that was actually over a stairwell, so it didn't really have a safe means of maintaining that. So a lot of these things are common sense, so making sure that what you can design can be safely maintained. The one on the right there shows very high level windows, and they've put a little platform in there to clean them. And obviously the more creative your design, the more challenges there, but there are products that you can use like self-cleaning glass. You can work out methods of overcoming any design issues as far as maintenance goes. So just using creative solutions to come up with to address potential maintenance issues. I mentioned before about relocating plant to the ground to allow it to be easily maintained. So there's some air conditioner units located on the ground, and cleaning windows from the inside if they're working at height, so things like louvers which allow for easy maintenance. On the left there, those lights have not been designed to be easily maintained. It can be things like also specifying long life lighting like LED lighting rather than incandescent or halogens. Making sure that you have access to plant and lighting. So the example on the right there has the plant accessible from that balcony area and the lights up there as well. So the thought has gone into this design to ensure that these things can be safely maintained. So another thing to consider during maintenance is things like corrosion. So the example on the right uses ColourBond Ultra. It's in a coastal location. The fixings and fittings that are used have been designed to be anti-corrosive. So this will decrease the need for maintenance and working on the roof at heights and potential hazards to workers. Or you can just decide to design a building that is meant to rust and doesn't need to be maintained. When you're looking at accessing the roof safely, I did mention firstly the best way to address that hazard is to eliminate the risk by putting the plant on the ground. But this may not always be possible. It may be that the plant might be tampered with or that there's no room on the ground for plant. So in some cases you will have to put plant on the roof. If you are doing so, you can see here on the left is a ladder access. Now this isn't ideal because you have to maintain 3 points of contact with a ladder at all times. So you can't actually carry parts up to maintain that. So you'd need some kind of mechanical way to lift parts up to the roof. The example on the right is a cage ladder, which is safer for the worker to walk up, but still doesn't address the issue of getting plant onto the roof. Ideally, if you do have plant located on the roof, having an access stair up to the roof and a plant platform so that the plant can be safely maintained. The legislation requires you to eliminate or minimise confined spaces, so things like grease traps that don't need to be entered to be maintained, rainwater tanks that you don't need to enter. And if you do have confined spaces that need to be entered, you may consider things like putting anchor points above those so that they can be safely accessed for maintenance. And this is an example of a UK building where they've actually integrated the protection for the cleaning into the cladding. So on the right there you can see that there's platforms off the windows so they can go and clean each of the high level windows. And then you can see the little cherry picker there on the left, which is specifically designed to clean those sections of the windows. And there's a perimeter path around there so that that can operate along the edge there and clean those windows. So they have considered at design stage how this building can be safely maintained. And it's important when you're doing things like high-rise buildings that you might consult with a facade consultant on how the facade that you have designed can be maintained to make sure that you're thinking about the safety of workers and coming up with innovative solutions. This is an example of the Globe Tower in London. So the previous tower was dark and was unlit. So when they decided to light up the tower, they came up with a solution on how they could actually maintain and replace that lighting safely. So using things like fibre optic lighting, which has a longer life and needs less maintenance, and also having access there for maintenance of that lighting. This example is of an outdoor sculpture at Cammeray in Sydney, and this is one I spotted when I was out in Sydney, and one of the issues here was that the material with which this sculpture was made was a corrosive type material and had been marking the ground pavement below, so they had to treat this sculpture to ensure that that didn't occur. They've also put a glass balustrade around the sculpture so that people can't climb on it. So it's about thinking about how these things, to reduce the need of maintenance, what types of materials can you use? Is there a material that will give you the same effect that won't require ongoing maintenance and people working at heights to maintain that? Another thing that was really interesting about this one was that there was a car park below that courtyard. So the consideration had to be given to the fact that there may be plant operating up on the courtyard to maintain that sculpture and making sure that the roof of the car park could take the load of that plant operating there. So that's sort of some of the things that you can consider. If you're designing a sculpture in a central space and there's a car park below, that's something the designer can have control of or consult with the engineer about the best solution. So maintenance is about making sure you reduce things like working at heights, making sure that what you design can be safely maintained. Usual things like putting anchor points on the roof, any potential hazardous substances in the building that may be an issue for maintenance, and reducing the need to enter confined spaces. It's also about selecting durable materials, so things that will not require a lot of maintenance. The last part of the life cycle we're looking at is the demolition. So this is an area where I find that architects have the most issue. The questions are like, how can we know how a building will be demolished in 50 years' time? So you need to base it firstly on current demolition techniques. So that's what the Code of Practice recommends. But if you read the Demolition Code of Practice, the areas of concern are high-risk construction work, like things like large cantilevers, suspended structures, pre- or post-tensioned slabs or members, and things like tilt panels construction. So these are all high-risk demolition work. So there might be specific requirements or guidance, like, for example, tilt panels need to be erected in a certain sequence and they should be demolished in the reverse sequence. We had one situation with an architect where they'd had an issue with a builder cutting into a slab and they didn't realise the slab was tensioned because it didn't mention it on the drawings that they had available. So this was an important lesson, I think, to make sure that if you do have things like tension slabs, to indicate that on the drawings so that if someone does make a change to that or demolishes that slab, that they're aware of that potential issue. So there might be something you've designed that needs special disposal, so indicating those things, particularly not only in the safety report but on the plans, is very important for demolition, because the safety report may go missing. It might be 50 years from now. So having that on the plans and having that lodged to council is a great way to communicate any potential issues for demolition. All right, we'll just move on to reporting and record keeping. So what types of information do you need to provide to show that you've fulfilled your duties under the legislation? So there's a safe design report, a work health and safety file, and a safe design plan. And these are all mentioned in the Safe Design of Structures Code of Practice. So the safe design report is firstly about identifying any hazards, and I mentioned before determining whether they're covered by a standard control or whether that standard control is inadequate, and doing a risk assessment of any potential hazards. You then need to indicate the design controls that you've implemented to eliminate or reduce that risk and show the revised risk level. And you also need to communicate any residual risks from that design stage to persons further down in the life cycle of that structure. So that could be communicating a potential hazard during construction, or something that should be incorporated into the maintenance plan or the operations manual of that building if there's something that hasn't been eliminated. So the best way to document the safe design information is in a risk register or report. And there's a code of practice of how to manage work health and safety risks that can be very helpful about a process for that. A work health and safety file is also recommended by the Code of Practice. Now this can be an actual Word file, or it could be a folder on your server for each job, which is labelled Safe Design, in which you put any records of any consultation that you have undertaken in relation to safety, the results of any research and testing that you've undertaken. It might be emails between you and the client, or you and the plant designer or the engineer. Notes from workshops, so you might want to hold a safety and design workshop for your projects at 1 or 2 during various stages of the project, especially for more complex projects. And there is a process called the chair process, which is really great to look at if you're looking at holding safety workshops. And then your risk assessment as well, and you can update that throughout the process. A safe design plan is also something that's great. I mentioned earlier about communicating information on the plans rather than in the report, because the report can go missing. So this is about things like that might affect there. So notes on the plans of any potential hazards. We do have some residential notes that we have developed for residential plans. So you can put those on, and evaluating any potential hazards, alerting people through the notes, the builder and the other people, of any hazards or residual risks. And it's also about the site features, so the setbacks from boundaries. Are there any overhead power lines, or is there a high voltage power line running underneath? Is the site really sloped, or is there contaminated soil on the site? All of that information can go on the plan. And you can have a specific plan that is just a safe design plan, so that that information can be easily accessed. All right, we'll just start the case study now. So this is a project that we were involved with as a safety consultant, and we carried out workshops with the City of Sydney and Neeson Murcutt Architects on the Prince Alfred Park pool upgrade. So I'm sure a lot of you are familiar with this design. It's in Sydney, and it's in Prince Alfred Park. So the concept was that they wanted to permeate, and they mentioned the word permeate, landscape over built form based on the conviction that in these inner urban areas, green space is sacred. So they almost wanted to crown this building in this grass mound to kind of get that effect of bringing the landscape over the built form. So that was a particularly important part of their concept, and they didn't want safety to impact on that. And this is a great example of how they've managed this issue. So their preliminary investigations revealed that there were some buildings that needed to be demolished on site. There were they conducted a hazardous materials survey. There was things like asbestos in the existing buildings. The access and public domain were an issue because it was in a very public location. There was contaminated soil also on the site, so that had to be managed as well. And there was a large underground high voltage main that ran right through the site. So that's a section through the building there. And they actually selected a construction system for safety, and working on that grass roof was actually reduced the risk of working at heights because the roof was actually on the ground because it was a grass mound. So in some cases on the left side there you can see that there was a reduced risk of working at heights, but there was still the risk of working at heights where it was projected out over the pool terrace. So there were also exclusion zones required around objects. So they put the palm trees in earlier, so they needed to maintain exclusion zones around those. There was potential falls from heights, as I mentioned, not only from that roof, but also into the pool. And they needed to make sure that was a potential issue for safety, making sure that those areas were excluded. So when they were looking at the use of any hazards for the use, they did a lot of testing on the ground surfaces to ensure that the ground surfaces were suitable for the purpose. So things like slip resistance testing of the materials that they used. There were some plaques there that had a historical value, and they were put throughout the pool area. And these plaques were made of metal, so they needed to have a treatment on them so they weren't slippery. So they tested all different types of surfaces to ensure that they had the right slip resistance. And they're also undertaking ongoing testing of the resin treatment to the metal tree grates to prevent the people burning their bare feet on these tree grates. So they're testing different systems at the moment to come up with the best solution. Durability was also considered, so they used corrosion-resistant materials, vandal-resistant fittings and fixtures, and anti-graffiti coatings. The waterproofing had some potential hazards there, but it was selected for durability, so that was actually put out as a management of a residual risk there to the builder. Accessibility, so they made sure that there was emergency vehicle access for so that this was an engineered pathway that could take the weight of any emergency vehicles coming in, and that the whole complex was fully accessible for persons with disabilities. So these tri-generation chimneys were put in as part of the ventilation system, so which improves the ventilation and air quality for workers and users. But they consulted with the engineers, and these became sculptural features that actually projected out of the ground. And they had function, but they also were safe as well, and they were a feature for the design. The skylights were the same, so these projected up out of the ground and lit the areas below. And they were designed to withstand the load of a person impacting those as well. And they brought in natural light to the areas below. So environment is also part of safety. So you need to consider the safety of people in the vicinity of that workplace, and that does include the environment as well. So having a low eco footprint is also part of safety. So things like energy efficient lighting, heating and water saving devices were used in this design as well. The major feature of this design was the grass mound roof. So this did pose a few issues. One of the issues that came up was around use, so the unauthorised access and potential people falling off the roof there. So what they did as a solution was they designed a fence that was a minimum of 2 metres high around that wall, rather than putting a balustrade right along the edge of the front there, which would have just ruined the effect of that grass edge. They put a fence and set that back, but angled it backwards and designed it to prevent footholds. The fence was also wired to a security system which went back to the City of Sydney, and there were security cameras installed. There were warning signs, and there was also lighting below on that pool deck which lit up that edge so that you could clearly see the edge, and it was delineated. Now the choice of grasses they used, they were a native clumping grass, so that stopped people being able to sort of run up there and jump off and things like that. So the whole system was designed to keep that same design intent of that grass roof, but yet to manage the potential of people having unauthorised access to that structure. The maintenance controls they used, I mentioned the choice of grasses, so it's a native clumping grass, which is a low maintenance grass, so they don't need to get lawnmowers up there to mow it. So they chose that particular type of grass. They also installed an evolution safety rail along the top there so that you could clip onto that when you were weeding the grass. There's a wide tiled edge which gives you separation there from the edge, and an irrigation system installed so that you don't need to go up on the roof to maintain that roof. So they selected, I mentioned earlier, other maintenance reduction issues were things like the selection of the materials, so the anti-corrosive materials and anti-graffiti materials. Things like hard-wearing surfaces, they were all considered during the design stage. They also eliminated or minimised the risk of working at heights to maintain the outdoor lighting by using pivoting outdoor lighting. So you can see in the middle there, It's in a small picture, and you can see in the top picture as well that there are lights that kind of pivot downwards, and that allows you to change those light globes without having to go up high to do so. So they pivot downwards to allow them to be changed. That you can't see it in these pictures, but there's actually an access hatch for the crane to access the plant room below. So rather than trying to bring plant in and down the stairs through the pool deck area, there's a concrete hatch which is buried under the grass, which they can use if they need to replace some of the pool plant, so that the grass can come off and that hatch can come up. They've also got a special location for a crane that can be used in that situation, so they made sure that there was an area designated for the crane to be able to access that plant room for replacement of the plant. Other maintenance issues were things like the removable umbrellas. They were installed so they were actually 2.4 metres high, so that people couldn't swing on them and break them. If they were broken for some reason, there were replacement umbrellas that would come in and immediately be replaced in, and they would be taken off site to repair, so that people wouldn't trip on the brackets left from those umbrellas. So the PA Pool Park upgrade is an outstanding design project, and it does display innovation and creativity, but it does achieve also the safe design outcomes. So this was achieved with consultation between the client, the City of Sydney, the architect, the engineers, and everyone working together. The City of Sydney maintenance people were consulted throughout the process, so to ensure the safety of workers and users of the structure. So this is a great example of how safety and innovation can combine. So where do we go from here? So firstly, I would recommend that everyone reads the Code of Practice on the Safe Design of Structures. I do usually ask in my presentations if anyone's read the Code of Practice, and there's usually not very many people that have. So that's a great place to start. There's great information in there. And there's also a lot of other codes of practice which you need to read. And I mentioned before things like high-risk construction work, asbestos, crane operation. There's some information in there that you need to know when you're assessing the safety of your structures. You need to document your safe design procedure. So you need a procedure in place, either developed internally or with an external consultant, about how you can practice safe design in your workplace. So you need to have a methodology that you follow and train your staff in there. You also need to ensure that your staff have a good knowledge of safe design, and that everyone involved in the design process communicates with each other and shares potential hazards and works together. You need to consider safe design early in the design process. So the intent of the legislation is that we consider safety early in the process so that we can design to eliminate or minimise potential hazards. You need to consult with stakeholders and other designers, and also research materials and processes to improve safety throughout your designs. It's very important that you keep records. So I mentioned before the ways of keeping records, things like the work health and safety file, and document all of your risk assessment and reports in your safe design report, and keep that information for the life cycle of that whole structure.